later on. I guess it could be related to this class if we end up doing something we want it to look good. So the idea is our applications, and this kind of bridges between some of the classes I teach and some of the classes that Professor Wall teaches with the animation, is there's this tool called Cory Animator. It's on the Mac App Store. It's for Apple only. And there is a free trial off their website somewhere. You can download it. I think they said it ends like May 1st is when the trial expires or something. At least that's what they said with the thing that they sent me. And the idea is that you can come into, for example, just to give you a quick little idea of this, you can come into Cory Animator. So this is one of their tools. Each tutorial shows you two sides of it. They show you the side that is the Cory Animator part where you're actually creating the animations, and then the other part is how do you bring this into your iPhone or Mac app project. So like in Cory Animator, oh, that's not it. We got this. Once upon a time I had sound.
Project.
Oh, there we go.
We're going to be creating this project.
So here's the idea. I'm just going to forward.
Two elements.
They teach you how to use the tool, and I'll just kind of scroll down to the end.
And drag them over to 0. And so now I have, we talked about easing styles.
So in the end, they have basically a trash can whose lid opens and closes.
That's
all right.
Basically it.
Now, once you have that, so this is in the tool where you create this animation. So that's all you're doing. This isn't programming or anything. It's just creating a trash can that has a lid that opens and closes. And those are two separate animations. One called closing, one's called closing, one's called open.
In the developer tutorial.
All right. So then what you can do is you can export that.
Welcome to this developer introductory tutorial. This is essentially a visual.
So inside of Cory Animator, you can hit export, and it lets you choose whether or not you want to export for Mac or iPhone, whether you want it to be for Objective-C or Apple's newer language, Swift. And then there's a couple other options for how you want the animation to actually export. So then in the end, what it does is it gives you a, let's see if I can, it gives you a folder called images that has all your images in it. And then it also gives you, so this was for Swift, it also gives you a single Swift file which has all the implementation of those animations built into it. So as native iOS code. So everything it looked like in Cory Animator has now turned into native iOS, either Swift or Objective-C code. So then what you can do is when you actually want to write this, or run this, in your, for those of you who've had the iPhone class, this will make some sense to you. You come into your projects, this is your zip file, now they use things called storyboards, but whatever. So you just drop a view in here, and then you change the view to be of type, that trash can view, the thing that you exported. And all of a sudden your trash can will show up in there. And then you can create an IB outlet associated with that, and you can tell it to add open or add close, and it'll just do that animation. It's actually kind of slick. So here, they just, right here they created the UI view. Right here they changed the name of it to be they changed the type instead of being a generic UI view. Now it's a, whatever, the trash VC, whatever the program exported for you. And then they show you hooking it up to code. So dragging in, creating your IB outlets. So here's your trash view. That's an IB outlet to this. And then here's a couple of buttons they end up putting down here for opening the lid and closing the lid. And then the code they put into those buttons are just 2 lines of code. 1 in each. So here's trash dot add open animation. So that'll make the lid open. Add close animation will make the lid close. So now when they run the app, they can click these buttons.
And that is the long, the short.
Hold on, I need to
close animation.
So they're launching it.
So we'll run that.
So now you just hit the button, open and close, and it does the whole animation that they made.
The close button closes back.
Yeah, that's because how they made the animation. Mine, I
And
didn't
that really
I
is
didn't
it
zoom in.
for the
I'm not an
basics of Cory
animator.
Animator. I hope you'll get to watch
The
some of the other
total amount
videos
of
for some
program that
other,
you have to write
techniques,
on your own
hope you've
was
seen
2
just
lines of
how
code.
easy it is to incorporate into a project.
2 lines of code to
For
make all that
developers wanting
happen. I
to
mean,
do
you
it,
had to
it's
understand
just
how
a
IB outlets and IB
bunch of
actions
methods
work,
you can
but
call that run the animations.
you only had to write 2 lines of
And
code
that is the
yourself.
long and
IB
short of it.
outlets were
Thanks
created
for
on your
watching.
own. IB actions were created automatically by dragging over there. I don't know, I thought it was pretty impressive. And kind of the thing I'm looking at for one of the apps I'm working on that I thought was kind of cool is, well, here's like a game they made where they created several different animations with an airplane. So they have like airplanes and birds and stuff like that, and then they bring all those animations into Xcode, and then Xcode has the logic for the game playing. Okay, so all these animations, you're not building the game in Cory Animator, you're building all the animations, and then you're getting those animations into Xcode as fully functional native animations. So you didn't have to write all that code to make your birds flap their wings in Xcode. But the one I think would be cool is this last one I was looking at, this dynamic content card. So what if you want to have a interface that looks real active on your iPhone app or your iPad app, whatever. So just to give you an idea of this, I don't think this was very
Hello,
long.
and welcome to another Cory Animator tutorial. In this video, we'll be exploring
They're showing
the
the
use of
actual
dynamic
game
content
here, the
inside
actual
of
app they
animated
wrote for
views.
iPhone here in the end. So this is running, this is in the simulator. So what they've done is they've shown, for the animator, they've actually just, each of these boxes is just a white box. What this color stuff we're seeing here is actually done in the Xcode side. This is just a view that has some red stuff on it, a couple of little dudes. So these are like information cards, almost like baseball cards for stats. Okay? But what they made in Cory Animator is just a grid, four wide by 2 tall, of white squares. All right? So what it lets you do, so they're showing the actual game here,
We'll
or
use
the
data
actual
that
app.
changes at runtime within the context of animations that have been created in Cory Animator. First, let's take a look at the finished product, and then we'll walk through the steps that we took to get there. We came up with this little project that displays.
So in Cory Animator, all they end up doing is animating blank white boxes. And all they do is move around on the screen and stuff like that. But since they each show up as a view, in Xcode, you can drop your own pretty baseball card looking things in there. So in the end, it'll look like
handful
this.
of players' basketball stats across a few teams. As we switch between the teams, we perform a fun animation to bring some interest to the content. We've taken advantage of the simplicity of Cory Animator to create several animations that we can choose from.
Isn't that cool? And no programming to do all that.
Now let's
Well,
take a look at
minimal
the Cory Animator
programming.
project. Here in Setup,
Yeah,
you can see
this
that we
is
have our
this
8
is their
views
animator
void of any
project.
content.
They're just animating white
These can
boxes.
serve as either placeholders or as
And
containers.
each of these come
we'll
into
demonstrate
Xcode as
how that
UI
works in
views, and
just
then
a
I
few
can just
moments.
drop
And
my baseball
here
card in
are
here.
our
I could drop my
animations.
baseball card
Each
in
one
here.
consists of
And
a
then my
pair
baseball
of
card is inside that UI
entrance
view
and exit
container, and when it goes
animations.
flying around, so does my baseball card.
We've already exported our project and
So,
included it in our
kind of an interesting tool for I think maybe computer scientists who are, or programmers, let's just say, who maybe have a skill set in writing the software, but not so much the skill set in making things look pretty. I mean, for writing, complex animations, you're still going to want to go to a designer who knows how to make things look good, and this is a good tool for making those animations, especially if your end game is to get it into Xcode, because this exports to it. But I think even for the generic programmer, you could make cool little like custom load screen things. Instead of just just the default spinning thing that it's waiting to load something, you can make little custom versions of that in 5 minutes. And now there's something special about your app or something, and it didn't take you much to do. Just build it real quick in Cory Animator, export it, and now whenever you want to show your custom spinner thing, you just drag it in there. Actually, it would probably be easier to do that than to use the built-in one, because the built-in one you have to wrap inside of a thread in order for it to work correctly. See, there's our segue to what we were talking about here, threads. Okay. So this automatically threads itself inside of its animation thing. I don't know, I thought it was a pretty cool tool. I may end up using this sum towards the end of 200 to do a couple of things, but kind of a neat tool. So I encourage you maybe to check it out if you're doing any iOS stuff. Okay, so this is not us. We're 440, and if I remember correctly, last time we were just getting ready to do something with some threads in our project, correct? I think we had done an example where, and I think this was actually 2 classes ago we did this example, but we had 2 or 3 of you, 4 of you, all try to hit the web server at the same time. And when we did that, when the web server was just spitting back some HTML, it didn't really seem like it was a big deal, right? Each of you you knew you hit it in a different order, but you all kind of got a response from the server. So you relied on the TCP/IP stack to kind of queue you up for you're next in line. But we saw an example there where we had the server do a bunch of work for one of the whoever connected first, right? I don't remember what we did. Did we print something to the screen 1,000 times or 10,000 times or something that took some time, right? So then whoever was the winner connected and would get the response. And all the other people were having to wait for the output here on the server to finish doing their crap. And I think that's the current state of our dealy flippy thingamabob server, right? Yeah, most of what we did last time was messing around with the web browser talking to this. The web browser became our client, correct? All right, so this should be in our last state, I think. Oh, no, we changed our server up. Whatever, doesn't matter. Well, it matters a little bit. Okay, here's our server. I'll leave some of that in there. Oh, I already turned it into a thread. So in driver, okay. So we had that. So let's show a broken version, but we'll do it with our website thing pretty easily. So what I'm going to do is I'm going to not spawn off a thread here initially. I'm going to bring some of this code back in to actually, I will do this. It's called response thread RT is equal to this. And then we'll say rt.run. All right.
You want it to run before it's said connected or after it's said connected?
Well, I guess it doesn't necessarily matter. They're all going to happen pretty quick. Because the connect is just going to print out to the server.
Yeah.
So I'm kind of cheating our thread implementation right now, just so I didn't have to bring all the crap back in here. I'm creating our response thread, which certainly sounds like a thread. And in fact, response thread extends thread. But rather than using the magical start method that comes with threads, I just go ahead and call the run method directly, which doesn't do any magical thread stuff. So this is not actually running as its own thread. So this guy would block. Okay. So right now, what does it do? It gets the input stream. It reads in the various parts, the HTTP requests, that kind of crap. Then we spit out index.html for the slash. Let's just make sure this guy's currently working. So I'll go ahead and get my driver running. And we will open up in Safari. What's the port? Is it 1234? Oh, guess we'll use Safari. Localhost :1234. What row?
Safari has trouble trying.
Safari won't have trouble. You watch. HTTP. Aha! That didn't work. It said connected.
When I was doing it before, I was trying to do it on Safari. I got it to like look at it, but it didn't show any HTML. And when I tried it on Google Chrome, it worked.
Really? That seems kind of dumb. That is dumb. I wonder. Well, we covered that last time. We haven't written a perfectly formed HTTP protocol server, so I'm guessing Safari must just have a default that doesn't like when you don't give it real stuff. All right, so fair enough. Let's look at the IP address of this machine real quick. See if it's probably different than it was last time. Network, where's network? Up there. All right, so current network address is 172.31.238.44. Colon 1234, and I need to start my server again. All right, so server is dead. All right, now it's waiting. Okay, somebody just connected. A couple people connected. 2 people connected. Both of you got home page. 3 people connected. You're all seeing the home page? Somebody's hitting refresh a lot of times. I even hear the clicks. All right, and the page is loading. No problem. Everybody's getting access to my awesome web server over here. All right, so now what we're going to do is after I tell it to run, I'm going to say for int I is equal to 0, I is less than 1,000,000. Is that 1,000,000? Whatever. I plus plus. System.out.hello. Kill that web server. .println wasting time. So this is when a single person connects. I will, and actually we will, I'm going to do this inside the thread. Will I? No, I'll still do it here. Won't make a difference. All right, so right here, I'm going to say I'm wasting time. I'm going to print out 100,000 things. No, I want to do it in the thread. That'll be the best example. So when you connect with the thread, it reads stuff in, it spits stuff out. Before the thread ends, we'll go ahead and just print stuff to the screen a bunch of times, saying wasting time. All right, so this will do it 1,000,000 times. So right now it outputs homepage, as long as you don't put in a specific request for like the hello one or anything like that. So we wait for connection, we accept the connection, we create our thread, but we don't use it as a thread. We tell our non-thread, well, our thread acting like a non-thread to run, which goes and serves the homepage page and then wastes a bunch of time. Okay, so I'm going to go ahead and run this. All right, so whoever wants to connect can go ahead and connect. Okay, somebody's gotten in there once, right? Other people trying to connect? I'll go ahead and refresh here. It's waiting. Can't connect. Can't connect. Why can't it connect? Well, my server hasn't gotten around to listening again. Trust me, it hasn't gotten around to listening again. Make sense? All right, so we're going to make one little change now. And now, instead of saying rt.run, I'm going to say rt.start, which does the thread magic stuff. It actually spawns it off as a thread. So we'll go ahead and hit start on here, so somebody can go ahead and connect. Somebody's connected. I've connected here as well. Gotta keep hitting refresh. Connected. I mean, the server's going to start feeling sluggish because that thread is sharing time with the CPU, right? But we're all able to get the home page to launch. Okay, because only so much of each of those threads' time is going to be allotted to the CPU for printing out wasting time. All right, so now we have a more functional web server that doesn't block when we have one page that gets stuck in a loop or something. Make sense? All right, so we would call this, let me go ahead and kill this now. When we use a thread, we would call this non-blocking. That is, when the thread spawns off, it allows our program to continue on and does not block the rest of the program from going. When we said rt.run, that is, we didn't use the magical thread method, now we have a program that blocks. This line does not finish until we've hit the end of this run method. And at the very end of the run method, we have a train wreck. Okay? So the very first fake thread that we create, the very first incoming connection that we respond to, has a train wreck at the end of the run method. And because this is taking, let's say, 5 minutes to do, however long it ends up taking, this line does not finish for that 5 minutes, which means we don't spin back up to here and we don't wait again for another incoming connection. All right, so when whoever got in first, whenever the second, third, fourth person tried to connect, they hit basically a busy signal. There was nobody on their other end to pick up the phone, okay, because we were not back to this line of code because the first guy was being blocked right here. By changing this to start, using the thread, now the start method does the magical thread stuff in the background, which says this line will not block. We will do the magical internal process thread scheduling stuff associated with this operating system and how it handles threads per process, whatever that means. But after this line, we will immediately go back to waiting. Immediately go back to waiting. Make sense? Okay. Didn't we see by, well, doesn't matter. I was just going to show you a different example of it, but that's pretty clear. Okay. So multi-threading is actually a pretty important part of having servers responding to things, especially if you want to handle more than one user. If we go back historically, when you had a single user communicating with a single program on the local machine, we may have said threading wasn't all that important, right? But then we started using our computers differently. I think I maybe used the example of if you were using an older Macintosh computer that was running before OS X, they had something called Pre-Emptive Multitasking. So let's just call that fake multitasking. So whatever program you had in the foreground was getting most of the CPU time. All the rest of the programs that you had minimized or running in the background were getting just enough CPU time to stay alive. So you might start a file downloading, put it in the background, and come back and check it in 3 hours when it should be done and it's barely made any progress. But it did make a little progress. It was dropping down to 2 bits a minute or something like that. So going very, very, very slow. And even before that, before we even had that level of it, we didn't even have multitasking at all. I mean, can you imagine using your computers today without multitasking? Without being able to do more than one thing at once? Don't we typically have our email open in the background and that's doing its stuff, or even thinking about our cell phones. Our smartphones, you might have Pandora playing at the same time you're getting email, at the same time you would like to get text messages as well, right? That's just 3 things right there. What's up?
I said botting 2 games.
Yeah, botting 2 games. Well, not from the cell phone. I'm checking in. Okay, but yeah, that's a good example of multitasking. Okay, if I couldn't multitask on Windows, then I wouldn't be able to play 2 video games when I'm not there at the same time.
Not play 2 at the same time.
Not play 2, no, playing 2.
Played for you.
Play for me, yeah.
Oh, yeah, you're not playing either of them.
Right, I'm not playing either. That's true. My account is technically logged in and my character is moving. That's what's happening. And I'm not present in the home. He happens to be killing things. All right. So we can think about the hardship of multitasking on a computer, right, when we didn't have that. And would the problem have been that our computer was too slow? So we roll back the clock to the days where we had computers that did not have multitasking. The problem was software, not that our computers couldn't handle more than one thing at once. Even in the early days of computers, when we would think, okay, these computers are really, really, really slow, they were still a whole lot faster than people were. You know, if we think about relatively lightweight applications, is there a great reason why we couldn't have a text editor open and a, let's say, what else do we have to go to early windowing environments? So let's just use the early version of Microsoft Windows 3.1. Shouldn't we have been able to have Notepad and Microsoft Paint open at the same time? We think of both of those as fairly lightweight applications, not really taking up tons and tons of system resources. So probably computers back then could have handled, from a speed perspective, could have handled both of those applications, right? Okay, no big deal. But our limitation was the software. Our software did not support, the operating system didn't support having more than one program running at once. Okay? So the limitation was the software. Now, if we look at networking today, and well, roll back the clock a little bit, networking today, we're kind of in a growth period. But let's go back 10 years ago, where bandwidth was really the bottleneck. You know, bandwidth is much more available today than it was 10 years ago. So go back 10 years ago, the way we would look at multitasking over a network would be a little bit different. Okay? The resource that we're sharing, different from multitasking on a PC, wasn't the CPU speed and the local memory. Instead, the resource we were sharing is bandwidth. Okay? That was the bottleneck, not the processing power on the computer on the other end. Right? Because we saw with our little web server here, the processing power on the computer on the other end is just taking incoming requests and serving on a web page. So it's just pushing stuff over that socket connection between the sender and the receiver, and that's not that much data. But when you have a lot of people connecting at the same time, you had a lot of users using that computer at the same time, that server at the same time, your bottleneck becomes the bandwidth. Okay, so when we're dealing with home computers, we never had to deal with a problem where you had more than one human working at the computer at the same time. You'd be fighting over the keyboard, right? Okay, so multitasking was really there to serve the one person using the computer. When we start thinking about network-aware or server-type operating systems, what they're doing is they are providing tools that allow multiple individual people to connect to the machine at once. Okay, so now you have more users, each trying to open up 1 or 2 or 3 applications. Even if it's just one application per user, if you have 500 users connecting to that server, that's as if it's one person sitting in front of the computer with 500 applications open at once. Kind of make sense? So because of computer networking, the problems that our operating systems had to start handling became different types of problems. If you're on a local network, our problem, we have less of an issue. In terms of moving data, because we have more bandwidth, right? If I'm transferring stuff between my computer and State Farm's computer over our wireless here, whatever it is it wireless N now, or is it still G? Whatever it is, you know, our bandwidth is going to be probably better than if he was sharing it from a DSL connection at home, because I'm limited by his upload speed for how fast I can receive things from him. All right, so our problems of how we use computers changed as the internet became kind of a reality. So multitasking / multi-threading, doing more than one thing seemingly at the same time. Sharing one or more resources among multiple users. I'm going to put users in quotes. So that could be one user requesting to use the CPU for Microsoft Word and also for their email client. It could also be multiple individual users all trying to open up a text editor at the Unix prompt or something like that. Okay, so sharing one or more resources among multiple users, or you might even say, or requests, where the source of a request could be from one user or many, many users. Okay, so just like I said a week ago or something like that, that I want us to stop thinking about networking as the internet. There's more to it than that. The same thing goes for thinking about computing as being a CPU-centric problem. The CPU is one resource we might want to share. You know, it's kind of human nature when we think about a computer, we think about the thing in the middle that does the computing. Okay, but all problems we solve in computers deal with the resources that we're sharing. That could be the hard drive on the computer, the CPU, the memory. So now when we start dealing with today's computing, we take for granted that all our computers today are connected to the network in some way, right? I mean, we notice right off the bat if we are using our computer and for some reason the network's not working. Like, oh, the internet's down. Okay, we notice that. Well, you roll the clock back, you know, even in the early days of the internet, you know, well, first of all, you knew you weren't going to have internet connectivity if you didn't have a plug plugged into your computer. You wouldn't have been surprised. Like, okay, well, I'm on a bus using my laptop. I have 15 seconds of battery life, and my laptop weighs as much as a suitcase. Can't check my email because, well, first of all, email's not invented. But secondly, I do not have an Ethernet cord tethered to my laptop dragging behind the bus. All right? We live in a very different world now. Now we don't even have the laptop. We're just on our smartphone using our data plan from the cell towers to check our email, right? Okay, even today, data plans on your cell phones are, I mean, they've become, you know, like they've started making profit off selling us more data than we need. When in the early days of data plans, they could only give us so much data and we typically needed more. And they charged a lot for it. So most of it, how many of you in here have a data plan of some type on your smartphone? Okay. Now, some of you are probably grandfathered into some sort of unlimited data plan, possibly. Others are under the lie that you're on an unlimited plan because they say it's unlimited, but as soon as you get past whatever they decide is enough, they basically make it so your data plan is on but not really working. They throttle you back to unusable speeds. Okay, but we pay for data plans. So generally speaking, for instance, right now AT&T has a plan with their data stuff where you can get 30 gigabytes of data shared across all your family share stuff for the price of 15 gigabytes. That's a decent enough deal. Well, how many of us use 30 gigabytes a month on our cell phone? Probably very few of us. You'd have to try. You'd have to really, really try. Why? Well, because most of the places we're at have Wi-Fi. Cell phone companies are taking advantage of that. They figure, fine, we give them the illusion that you need lots and lots of bandwidth to be able to do your stuff, but we also take advantage of the fact that most of the time they're going to be using somebody else's bandwidth on their devices. So to make you feel a little better, what do? They give you rollover data. Now it rolls over 1 month. So like, oh, I didn't quite use my 30 gigabytes this month, so at least I'll get a little extra for next month. Something like that. But what happens? Well, we got grandfathered into a good deal, so we won't drop down because we'll lose the deal. This is where these places are making their money. In the early days of smartphone data plans, you maybe could get 144 kilobits per second transfer speed. So we're talking about two separate things here. Transfer speed was that. Today's transfer speed, you might have 20, 30, 40 megabits per second, depending on if you're LTE, whatever. So a lot faster today, but the bandwidth you got back then might have been something like 5 megabytes. Anything over 5 megabytes, you had to pay, $100 or something, something like that. I remember for a long time, the cap was 5 gigabytes. And this is even relatively recently. Anything over 5 gigabytes, you had to pay an arm and a leg for more data. But 5 gigabytes was typically pretty expensive. So you were paying, let's say, $60 or $70 a month for one of these data, specialty data cards that you would plug into your laptop, and that guy would give you, as much data as you wanted to pay for, but your plan was typically 5 gigabytes a month. And you could go through 5 gigabytes pretty quickly. How many of you in here use at least 5 gigabytes of cellular data every month? How many of you don't know how much you use? Is that most of you? Really? Nobody in here uses 5 gigabytes of cellular data? Yeah, see, it's really working. That whole plan. How many of you in here have unlimited data on your plans? Okay. The quotes. Who's your provider? Okay. Oh, so your grandfather is an old iPhone plan? Yeah. Oh man, I dropped that. I had the unlimited data on my iPhone plan, but I wanted to have tethering. You change that plan at all, it falls off. You cannot touch that plan ever. But in any case, my wife and I, across between 2 iPhones, we typically use around 10 gigabytes a month. We only use more when we're traveling, and I'm tethering a lot to my laptop or something like that. So, it becomes an interesting problem. But 5 gigabytes would not cut it. And most of that data is probably me. I'm guessing I probably use 7 or 8 gigabytes myself. So I like watching YouTube while I'm driving. Streaming Netflix while I'm driving. Well, I got this big screen. I got a nice mount. I can put it right in front of me. I have a helmet. Okay, so in any case, our problem today when we deal with network type communication, the slowdown is that communication channel between the 2 endpoints, right? The computers on either side can handle whatever we're asking them to handle. The bandwidth is the problem in the middle. That's the issue that we have to deal with when we deal with multitasking or multi-threading network applications, which are talking to a single central point, that is a server, and having multiple clients connect to that server. So this model is called the client-server model. One server serving data to 0 or more clients. A server can be thought of as a physical computer. A single physical computer may be running multiple software servers providing various network services. Okay, so if we take a physical server as an example, and this physical server is handling all of a major corporation's web traffic. So let's take like Northwestern Mutual, okay, big company. Chances are they have at least one server. Let's just say one does it. So they probably have a pretty expensive, pretty powerful piece of equipment, computer, that's running a web server on it. And that's all that piece of equipment is for. It's running a single copy of Apache, which is a multi-threaded application, and that server, that one piece of equipment, handles all of the traffic for Northwestern Mutual's website. Okay, fair enough. Now we're going to take Bob's fish store, Bob's pet store, pet stop, pet shop. Well, let's say he runs his own email server, his own print server, and his own web server. Does Bob need 3 different computers? Or probably less traffic across the website and the email for a pet store? So Bob can probably just get a refurbished e-machine off of eBay, like a really crappy old computer, and run as many servers as he wants on it, and there'll be plenty of computational power to keep Bob's Pet Store up and running. Okay, so that would be an example where you have one piece of hardware that has substantially less power than the one piece of hardware at Northwestern Mutual, and it's actually running multiple servers, software servers on it, to handle the email and the web and the print sharing for all of Bob's Pet Store. Make sense? Where email server at Northwestern Mutual is probably another physical computer. With a whole bunch of security concerns as well. Northwestern Mutual sells life insurance, so anytime you're dealing with money, you have to deal with a lot of other security concerns and stuff like that. So that server is having to do extra work over and above normal email crap. Okay, so that's our client server model, which was a very popular model for years and years and years. And we still experience this model today, well, because we're still using this internet that, we've kind of were grandfathered into. Is the way we interact with web pages in terms of typing in www.google.com, pressing enter, is that any different today than it was a decade ago?
Yes.
Yeah.
You have to type in www.
Oh, actually a decade ago you wouldn't have had to either. Okay, who's typing in? Yeah, the web browser's doing it for you. Okay, so it's just a magical text box. But really, the way we interact with our web browsers isn't any different today than it was a decade ago. Our websites might be a little bit more dynamic today. We have some newer technologies that allow web programmers to do some cool stuff. So you might say that the nature of the content has evolved. Part of it because of the technology, another part of it because of the bandwidth. In the early days of the internet, most of our home pages, at least, nobody calls it a home page anymore. They used to be called home pages. Like, oh, find me on the web at my home page, which is www. blah, blah, blah. There was a bunch of sites out there that would allow you to create your own home page. So when you gave somebody your home page, you would say, like www. imastupidwebserver.com/mlitman, smiley face, but all this crap. What was it eSites? Echo Cities? GeoCities. I think GeoCities was one of the original centralized hosts that people could make their web pages on there, their home pages. But in any case, nothing's really changed, but our bandwidth has. So in the early days of web pages, you really had to be careful about how, the types of images you put on there. In the first version of the internet, all of our images were bitmaps, which are there's zero compression with bitmaps, at least natively built into the image format. So a bitmap image was a very large file. And back then, you had very slow modems. So loading an image, you might be looking at, when you go to a page now, and almost like passively, the Google image just shows up, right? Probably was cached 6 months ago on your machine, and they just check to see if there's a new version of it. But even if it wasn't cached, it would just show up real quickly, right? In the early days of the internet, they used that exact same image, and most of us would say that Google's homepage is as plain as they get, right? You don't get a much simpler website than this. I bet you in the early days of the internet, this one image would have taken about 2 minutes to load. You'd have seen it show up like one line at a time. And you'd be sitting there saying, oh my gosh, there's graphics. So excited, there's graphics. Because a lot of web pages had didn't have any graphics, so they would load quicker. And even before that, did you know there was text-based web browsers? Yeah, our original web browsers weren't like this. What's a web browser? It translates HTML into readable text. So there was I'm actually interested in whether or not the Mac terminal. Oh, it's right here. It looks like. I think one of them was called links. Use the terminal as a web browser. You'd have to install the program.
It's like challenging to do it now.
Yeah, you should just be part of it. Yeah, if I remember correctly, the it was called Links, was the command line web browser.
Yeah, this is a 4.
Links. Oh yeah, look at that. Oh yeah. Does it show an example of what a links delivered website would look like? There we go. Wikipedia. Look at that. That's your Wikipedia site. Who needs a GUI? So, in any case, these were problems early on, but we still use this client-server model today because we're grandfathered into it. But we've started seeing over the last several years new models coming about that deal with this idea that bandwidth is our, upload bandwidth is our enemy right now. Like we talked about earlier in this course, all of us, even though we didn't know how fast our internet connections are, all of us have a faster download speed than we have an upload speed. And if you don't, you definitely know you don't because you paid somebody for a synchronous connection. I think Verizon, their Fios service, I think they have a high-end option to have a synchronous 100 megabit by 100 megabit connection, but it's not cheap. So it is technically possible you have a synchronous connection, but if you did, you would definitely know how fast your internet was because your bill would be something serious. Okay. But most of us have internet connections that are substantially faster download speed than they are upload speed. Like I said, I think I'm paying for 100 megabit down, and I'm pretty sure my up is like 5 advertised. Okay, 5 megabytes. It might be 10 now that they jumped from 50 to 100. I just have whatever their fastest is at the time. But regardless, a lot slower upload. Well, my upload is somebody else's download. And we're already starting to deal with new models. For instance, patching operating systems, patching video games, things like this, where now we're delivering data that isn't small data. We're not, when we're downloading a patch to a major patch to a video game, it could be a 1 or 2 gigabyte download. Huh?
Those are horrible.
Well, on campus.
No, on campus they're great. If it's working.
I don't even think about a 1 or 2 gigabyte download. That's like nothing.
Oh, at home it takes weeks. They're horrible.
The Amish are delivering it by wheelbarrow.
That might be fast.
They have little fish nets that they've kind of dipped in jelly to hold the bits in.
And they keep on falling out.
So, in any case, we start looking at distributed networks. I'll just give myself a reminder here. Trying to solve the client-server dilemma. All right, so for Monday, thought I was going to forget. Yeah. Okay.
I just think class is over, so you don't have time.
Well, you could choose not to do it if you want. It's easy for me to give you 0. I actually was going to have you have you do a little programming thing. But what I want you to do is I want you to write a 1-page paper.
I would rather do.
No, I basically want a bulleted list. Hey, this is a free assignment. I'm giving you a free assignment. Okay? Go online. I want you to provide for me kind of a bulleted list with a little bit of description of at least 5 technologies that are distributed network solutions to a client-server model. Okay? A good starting point would be BitTorrent. Okay?
Technologies that what?
Just do BitTorrent competitors. I'll put it on Angel. Okay? But what we want to look at is we want to look at peer-to-peer networks. There's going to be various ones like that. You've heard someone like Napster. Okay? Those types of things. BitTorrent. So give me 5 technologies like that with a little blurb about how it works. Okay? 1 page. 1-page bulleted list. All right, and we'll come back and we're going to talk about that on Monday. Sound fair? All right. I will see everybody on Monday, and I'll put that up on Angel right now.